All right, in this video, I'm going to go over solving quadratic equations just with 3 different ways. I know there's 4 listed here for these methods. We're going to talk about using square roots to find the solutions. We're going to talk about factoring, which we've done a lot of practice with factoring. And then we'll talk about using the quadratic formula. And I'm going to encourage you guys to use the quadratic formula as like a last resort, right? If you're having trouble figuring out the factoring, then I would probably think about the quadratic formula. Please, 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 I encourage you. I know you can always use the quadratic formula to solve these. It just gets pretty clunky, takes a long time, so it's much more efficient to factor first, right? Always try to factor first. Okay, so with this idea, you're gonna see me or hear me and also read instructions, talk about ways to find these solutions. And so a solution for a quadratic equation or quadratic function that represents the x-intercepts of the equation. Okay, and so when we find x-intercepts, if you remember from your days in pre-algebra, right, x-intercepts means that you have some number in x and your y value is 0. So you'll notice, like with this first one, A, we're going to do, it's already set equal to 0. When we get into functions, the first thing we're going to do is we're going to set that function equal to 0, right? We're going to make the y value equal to 0, which will allow us to find those x-intercepts, okay? You're going to hear me refer to them as solutions, zeros, we'll refer to them as x-intercepts, as well as roots of these different quadratics, okay? So if you hear anything about finding solutions, zeros, x-intercepts, roots, it all means to do the same thing, okay? So right here is what I'm talking about. All right, let's find this first one here. So if x squared plus 121 equals 0. So notice on these 3, I'm not going to be doing any factoring, all right? And this first one is actually the sum of 2 squares, which is not a thing. You cannot factor that. So I'm going to move that 121 to the other side. Now, when you move that 121 to the other side, it becomes a negative. Now, I'm going to take the square root of this x squared, because the square root of x squared is going to be x. I'm trying to get x by itself. I also have to take the square root of that negative 121. So I have x equals plus or minus the square root of negative 121. Now, I think we do know the square root of 121, right? That's going to be 11. But because of that negative inside, which we just talked about in our last couple of videos with complex numbers, we cannot actually have any number that when you square it gives you a negative. So what we do when we have that negative in there is we're going to write that I. Right, so these 2 solutions are actually going to be imaginary solutions. And I'm not asking you to do this on the homework, but if you were to graph this, all right, essentially what it would look like is you would have this parabola, right, for a quadratic. But you notice when I drew that parabola, it does not have any x-intercepts. So whenever you have imaginary or complex solutions, you're not going to have any actual x-intercepts. Okay, let's do B. So I'm going to isolate for that x. So the first thing I'm going to do is divide both sides by 2, which gives me x minus 3 squared equals 49. Now, I see that minus 3 there, but it is inside parentheses that are being raised to the second power. So the next step I have to do to undo these operations is actually take the square root of both sides. So now I'm going to have x minus 3, right, taking the square root of something that's squared. Those are inverses of each other, so they just go away. Equals, and I know the square root of 49 is 7, but remember when you take the square root in your problem, right, when you actually do the square root operation in your work, you need to put plus or minus with your value, right, because you don't actually know which value it's going to be. It could be negative 7, could be positive 7. Now to finish this problem, I'm going to move that minus 3 over with addition. All right, so we end up getting 2 x-intercepts, or 2 solutions. We have positive 7 plus 3, which is going to be 10, or we have x equals negative 7 plus 3, which is going to be negative 4. All right, so when we do this, if I were to sketch it, all right, and again, I'm just making this up, but you have negative 4, you have positive 10, all right, and what you're going to do is you would make a parabola that has intercepts at those values, okay? So it crosses the x-axis at those numbers. Okay, let's do C. All right. So C, right, when I look here, is I'm going to move this minus 21 over first. So I'm going to have 3 times 2x plus 1 squared equals positive 21. Just like I did on the last one, I'm going to move that 3 that's in front, move that over with division. So 21 divided by 3 is going to be 7. All right, now I'm going to take the square root of both sides, which is going to be 2x plus 1 equals plus or minus the square root of 7. All right, now with the previous one, we had the square root of 49, so that had an actual value. I know that that's a perfect square, but 7 is a prime number, not a perfect square, so I'm not going to be able to get rid of that radical. I got to keep it. So now watch the work that I do here. I'm going to subtract 1 from both sides. So here's how we write it. We write negative 1 plus or minus the square root of 7. Put that number that's not in the radical in front of the plus or minus. Then I have to divide both sides by 2. So how we write this answer for the x-intercepts is negative 1 plus or minus the square root of 7 divided by 2. And I'm going to let you leave. You could use a calculator to find the approximations for those. But if you were to graph it, all right, do a quick little math here. Negative 1 minus the square root of 7. Square root of 7 is probably 2.7. All right, so going to be probably somewhere over here for your first x-intercept. And then negative 1 plus 2.7, probably somewhere here. So you're still going to have 2 x-intercepts. It's just we would have decimal approximations if I asked you to find the actual numbers there. But for now, this is totally fine. We'll leave it like this. All right, so that's solving by using your understanding of square roots. All right, if you can do that, please feel free to always do that. Let's get into probably the one that's going to be the most common, or at least the one I try to do if possible, and that's using factoring. Now, there is a property that I need to make sure that we go over, and we'll hit this a lot in class as well. All right, so factoring is kind of just, that's most of it. I'd say 90% of this is going to be can you factor it? But then if you don't really necessarily understand the rationale behind the zero product property, you may not actually fully grasp what we're trying to do. So let me show you in the first one. So this one, I noticed my a is 1. It's already set equal to 0. So if I make my little x here to help me, I have a times c that adds to b. So that's 1 times 10, which is 10, and b is negative 7. So like we've been practicing for at least a week now, I need 2 numbers that multiply to give me 10 and add to negative 7. So that's going to be negative 5 and negative 2. All right, that would make that true. So I told you guys when a is 1, like in this case, you can take those 2 numbers that you just wrote and put them in as your factors. So x minus 5 and x minus 2. Right? If I were to distribute that, I would return to this x squared minus 7x plus 10. Don't forget to bring that equals 0. Now here's the zero product property. Right, if I'm trying to figure out 6 times some number is going to be 0, I know that this has to be 0. If I'm trying to figure out some number times 4 is equal to 0, I know that that question mark has to be 0. Right, so if you can make one of your 2 numbers that are being multiplied together into 0, then the whole thing is going to be 0, right? Because when you multiply by 0, you get 0. So if I take each of these individually, right, if I take this factor and I make it equal to 0, the whole thing would be 0. So I'll give you an example. So if I do x minus 5 equals 0, move that minus 5 over, I get 5. All right, so that's going to be one of my x-intercepts. Watch what happens when I plug it in. If I plug in 5 here, I get 5 minus 5 times 5 minus 2. So that's 0, but 5 minus 2 is not 0. It's 3. But again, it doesn't matter because you only have to have one of them 0. If one is 0, the whole thing becomes 0 because we're multiplying. All right, so that's kind of the idea of the zero product property. If you can make one of your factors become 0, the whole thing is 0. So now do the same thing for the other one. Set x minus 2 equal to 0, and you get x equals positive 2. So both of these are going to be my x-intercepts. So if you were to graph it, we have 2, we have 5, so this is going to be our parabola. Again, just a sketch. All right, so that's factoring and then using the zero product property. Let's try B. All right, this time when I make this a times c that adds to b, I notice my a is not 1, it's 4. So 4 times c of 1 is going to be 4. My b is 4, so I need factors of 4 that add to 4, which is going to be 2 and 2. Now, because a is not 1, I'm going to rewrite 4x squared plus 4x plus 1, but I'm going to take this middle term of positive 4x, and I'm going to blow it up using those two numbers. So plus 2x plus 2x. Bring down the plus 1. You can write the equals 0. It's just going to come along for the ride, so no worries there. Let's do grouping. Out of those first two terms, I can take a 2x, which leaves me with 2x plus 1. Out of my next two terms, I can take out a plus 1, which leaves me 2x plus 1. Continue our grouping, and you should notice that this is actually a perfect square trinomial. All right, now the same thing applies, even though it was perfect square trinomial, it's still the zero product property applies here. I just need to make one of these become 0, and then the whole thing would be 0. Now you might notice they're exactly the same. So if you do the work for both, it's really just double the work. You just need to pick one and set that equal to 0. So this is actually going to have one root. It has one solution here. Move the 1 over with subtraction, and you get -1. Divide both sides by 2. You get x equals -1/2. So here's how this would look if you were to sketch it. You have -1/2 is here. So because you only have one x-intercept, you'll notice we don't actually pass through the x-axis. We just touch it and then come back with the rest of the parabola. All right? Okay, let's move on to part C. All right, now in part C, all right, I notice that it's not set equal to 0. So the first step is to move that 20 over with subtraction to set it equal to 0. Then I'm going to do my factoring with my a times c that adds to b. A is 1 again. C is -20. Right now I'm using, even though I changed the problem in terms of how it looks, I didn't actually change the equality. All right, still fine. All right, so you'll notice C is -20. B is -8. So I need two numbers that multiply to give me -20 and add to give me -8. I'm thinking 10 and 2 here. Let's try -10, +2. Yes, that would work. Because a is 1, I'm just going to write down x minus 10 and x plus 2. Set it equal to 0. And because of the zero product property, I'm going to set each of these factors equal to 0 separately. That will give me my two solutions to this equation. So x equals +10, x equals -2. So again, if I graph it, I got -2, +10. Those are going to be my two solutions. All right, so that's it for factoring using the zero product property. Got one more I'm going to go over, which is the quadratic formula. All right, so here it is. I'm going to help you guys memorize it in class. But the key thing here is I need you guys to know that this should be a last resort, right? If you're having trouble factoring, I would recommend waiting to do this, right? I would never recommend the quadratic formula unless I'm just like, you know what? I can't figure out how to factor this, so let's do the quadratic formula, all right? But really, this is just about plugging it in and then simplifying it. So there's not really a whole lot of thinking involved. You're going to copy down the formula. So we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so that's the quadratic formula. So in this first one, I have a is 2, b is -3, and c is -20. All right, so I said the first part was the opposite of b, and the opposite of -3 is a +3, plus or minus. Now watch, make sure when you plug in b, it is negative in this case, so please put it in parentheses, -4 times a times c, all over 2 times 2. Okay, I'm going to clean up inside that radical. So in that radical, I have -3 squared, which is 9. I have 4 times 2 times -20, which is going to be, I believe, -160. But you'll notice we have subtracting a negative, or if you were to take that negative in front of the 4 and multiply it as well, you're going to get addition here. So 4 times 2 times 20 is 160. So it's going to be 9 plus 160 inside that radical. So if you add those together, you get the square root of 169. Now, when I notice this, or when I notice about that 169, is that is a perfect square. So I know I'm using the quadratic formula for this problem, but if I were to actually solve this and it didn't say use the quadratic formula, I would not use the quadratic formula. If I get a perfect square inside my radical, that just tells me that I should have factored, okay? Now, if I keep going over here, I'm going to have x equals 3 plus or minus, and the square root of 169 is 13, all over 4. So set up two of them, right? We're expecting to have two answers here. 3 plus 13 over 4, and 3 minus 13 over 4, right? So that's going to be 16 fourths, and that's going to be negative 10 fourths. Feel free to reduce, leave as fractions. You can use decimals here with the negative 10 fourths, but it's up to you on what you want to do here. So that's going to be 4, and this is going to be, let's see, that's 2.5. All right, so that is it for A. Okay, let's find the x-intercepts for B. Now, the first thing I notice about B is I do not have everything on one side set equal to 0. So let's get everything to one side, set it equal to 0. I see a minus x squared over here, so I'm going to move that over with adding and get 9x squared on the left side. My 4x is going to stay there, but I want to move this 16 to the other side to be minus 16 equals 0. I don't have any GCF to factor out, and it wants me to use the quadratic formula, so I'm just going to write down the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 9, b is 4, and c is negative 16. So plugging in, I get the opposite of 4 plus or minus the square root of 4 squared minus 4 times 9 times negative 16, all over 2 times 9. All right, so let's clean up inside there. That's going to be 16. This will end up being addition, right? One thing you'll learn as you do more of these, if you have either your A or your C is negative, then you're going to end up having subtraction. So negative 4 times 9 times negative 16 is 576. Again, I do not know that off the top of my head. I used a calculator. Over 18. Continuing, I get x equals negative 4 plus or minus. That's going to be 592. I don't think that's a perfect square. I don't know for sure. But if I do some factoring over here, 592 can be divided by 2. Let's see, 592 divided by 2 is 296. Divide that by 2, you get 148. Divided by another 2, you get 74. Divided by 2, you get 37. So that actually breaks down to 16 times 37. So I'm going to write this down as the square root of 16 times 37. And when you do that, I hope you know the square root of 16 is 4. So I'm going to bring that out and leave that prime number of 37 in there. Now this last step is to look at the value here, the value in front of the radical, and the denominator to see if you can divide each of those by a number. And negative 4, 4, and 18 can all be divided by 2. So I'm going to write negative 2 plus or minus 2 times the square root of 37 all over 9. And unless I give you a calculator, you can just leave it like this. I'll probably give you a calculator for that square root of 592 or asking you to rationalize that. Okay, let's do one more, then we'll be finished. All right, this last one, again, if I had my own devices here in terms of like said, just solve it however you want, I would definitely try to factor first. And then if I couldn't, then I might use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So a is 2, b is 1, c is 5. So I have the opposite of 1 plus or minus the square root of 1 squared minus 4 times 2 times 5. Now I should say all over 2a. As I was writing that in there, I noticed nothing about the a or the c was negative. Neither one was. So it's going to be 1 minus 4 times 2 is 8, 8 times 5 is 40, all over 4. And that's going to give me a negative 1 plus or minus the square root of a negative 39 in the radical. All right, now 39 is actually a prime number, so I can't actually simplify that. But I hope you notice that we do have a negative inside the radical, which we have talked about. The square root of a negative 1 is the same as the letter I. So I would please like for you to put that I out front of the radical, and then you can write positive 39 inside. All right, so I'm expecting to see this for your solution. All right, so that's it for those 3 ways of using the square roots, using factoring, and then the quadratic formula. All right, try the homework. Come see me if you have any questions.